Hi, hello, this is Giri, teaching 9th Mathematics, the chapter Polynomials. Here are the questions and solutions from exercise 2.3 and this is part 3 video. In this video, we will learn the solutions of question number 6 and question number 7 of the exercise 2.3. Dear children, here is the chapter Polynomials and this is the exercise 2.3. Now, question number 6. If the polynomials x cube plus ax square plus 5 and x cube minus 2x square plus a are divided by x plus 2 leaves the same remainder, then find the value of a. I shall repeat. If the polynomials x cube plus ax square plus 5 and x cube minus 2x square plus a are divided by x plus 2 leaves the same remainder, then find the value of a. Now here we are given two polynomials. The first polynomial is x cube plus ax square plus 5. This is the third degree polynomial. And this is another polynomial x cube minus 2x square plus a is the second polynomial. Now, if the first polynomial is divided by x plus 2, then there may be some remainder. And if we divide the second polynomial with x plus 2, there may be some other remainder. But in the question it is given that they leaves the same remainder, means the remainders are equal. The remainder when the first polynomial is divided by x plus 2 is equal to the remainder when the second polynomial is divided by x plus 2. Now let us use the remainder theorem. Okay, let us use the remainder theorem to find the remainder when the first polynomial is divided by x plus 2. Similarly, again let us use the remainder theorem and let us find the remainder when the second polynomial is divided by x plus 2. And if you equate both the remainders, then you may get the value of a. Understood? Here, dear children, you see the solution now. We have given that p of x is equal to x cube plus ax square plus 5. Let us assume that the first polynomial is p of x. And the second polynomial x cube minus 2x square plus a is q of x. Is it clear? Good. Let us consider the first polynomial as p of x and let us consider the second polynomial as q of x. Now the first polynomial is divided by x plus 2. If p of x is divided by x plus 2, then what is the remainder using remainder theorem? Let us equate x plus 2 to 0. X plus 2 is equal to 0, then x is equal to how much? If we take this plus 2 to other side, then x is equal to minus 2. Therefore, the remainder is p of minus 2. Is it clear? Good. We solved so many questions basing on this remainder theorem already. If the polynomial p of x is divided by x plus 2, then the remainder is p of minus 2. Now, in this polynomial, in the place of x, if you substitute minus 2, then you will get the remainder, isn't it? Therefore, p of minus 2 is equal to x cube means minus 2 whole cube plus a into x square means minus 2 whole square plus 5. Now let us simplify this. Minus 2 whole cube minus whole power an odd number is always negative. Minus to the power an even number is always positive. Now minus whole cube is minus, 2 cube means 2 into 2 into 2. 2 2 is 4, 4 2 is 8. Therefore minus 2 whole cube is minus 8 plus minus 2 whole square is minus 2 into minus 2 is plus 4 plus 4 into a is plus 4a and this is plus 5. This is a term, 4a means it is a term and this is a constant term and this is a constant term. Therefore let us simplify these two. Minus 8 plus 5, these two are of different signs. Therefore, you subtract the least number from the highest, means 8 minus 5 is 3 and the greatest number with sign is negative, therefore it is minus 3. So, minus 8 plus 4a plus 5 is equal to 4a, minus 8 plus 5 is minus 3. This is the remainder when the first polynomial is divided by x plus 2. Similarly, let us consider the second polynomial q of x now and let us find the remainder when this q of x is divided by x plus 2. If q of x is divided by x plus 2, then the remainder is, with x plus 2 have to divide, therefore equate this to 0, then x is equal to minus 2. So q of minus 2. Okay, the remainder when qx is divided by x plus 2 is q of minus 2. To take this polynomial, q of x is equal to x cube minus 2x square plus a, and here in the place of x you substitute minus 2 now. Therefore q of minus 2 is equal to x cube means minus 2 whole cube minus 2x square minus 2 into minus 2 whole square plus a plus a. Minus 2 whole cube means minus 2 into minus 2 into minus 2 minus whole power, an odd number is minus 2 cube, 2 into 2 into 2 is 8. Similarly, this value minus 2 whole square is plus 4 into minus 2 is minus 8, and this is plus a. What is minus 8 minus 8? Minus 8 plus minus 8 is equal to minus 16 plus a, and this is the second remainder when the second polynomial is divided by x plus 2. The remainder when the first polynomial is divided by x plus 2 is 4a minus 3, and the remainder when the second polynomial is divided by x plus 2 is minus 16 plus a. But in the question it is given that there leaves the same remainder, means the remainders are equal. Since the remainders are equal, you can equate these two remainders. Okay. But it is given that the remainder on the first polynomial is divided by x plus 2 is p of minus 2 is equal to the remainder when the second polynomial divided by x plus 2 is q of minus 2. It is given that these two remainders are same, therefore p of minus 2 is equal to q of minus 2. What is p of minus 2? 4a minus 3 is equal to q of minus 2 is minus 16 plus a. Bring a terms to this side and constant terms to RHS. This is 4a and plus a this side minus a. 4a minus a is 3a. This is equal to minus 16 minus 3 this side plus 3. Minus 16 plus 3 is minus 13. Therefore a is equal to minus 13 by 3. Good. This is the value of a. Is it clear, boys? Very good. Now let us solve question number 7. Here is the chapter polynomials and the exercise 2.3, and this is question number 7. Find the remainder when f of x is equal to x power 4 minus 3x square plus 4 is divided by g of x is equal to x minus 2, and verify the result by actual division. I shall repeat. Find the remainder when f of x is equal to x power 4 minus 3x square plus 4 is divided by g of x is equal to x minus 2, and verify the result by actual division. Here, if you observe the question, we are given a fourth degree polynomial f of x is equal to x power 4 minus 3x square plus 4. Now we have to find the remainder when this is divided by x minus 2 in two ways, in two different methods. How to find remainder? So far we did this type of problems using remainder theorem. Okay. Now let us apply remainder theorem. Let us find the remainder when f of x is divided by x minus 2. Understood? Then you will get one remainder. Later you have to divide this with x minus 2 using general division method. Actual division, that operation we should perform. The remainder when we use the remainder theorem should be the same when you perform the division, actual division. Okay, let us see what will happen. You see, here is the solution now. First of all, we have given a polynomial f of x is equal to x power 4 minus 3x square plus 4, and another polynomial x minus 2, g of x is equal to x minus 2. Now we have to divide f of x with g of x. Understood? Therefore, if f of x is divided by g of x means x minus 2, then the remainder is, using remainder theorem, the remainder is f of plus 2, because x minus 2 is equal to 0, then x is equal to minus 2 other side plus 2. Therefore, in the place of x you have to substitute 2 and you have to find the value of f of 2. If you find the value of f of 2, that itself is the remainder when f of x is divided by x minus 2. Therefore, let us consider this polynomial x power 4 minus 3x square plus 4, and in the place of x you substitute 2 now. F of 2 is equal to x power 4, 2 power 4 minus 3 into x square means 2 square, and this is plus 4. What is 2 power 4? 2 into 2 into 2 into 2. 2 2 is 4, 4 4 16, minus 3 into 2 square is 4, 3 into 4 is 12, and this is plus 4. 16 plus 4 is 20, and this is minus 12. 20 minus 12 is 8. Therefore, if we apply remainder theorem to find the remainder when f of x is divided by x minus 2, we got the remainder as 8. Now let us perform the actual division, or let us divide x power 4 minus 3x square plus 4 with x minus 2 and verify what will be the remainder. Okay. Now the dividend is x power 4 minus 3x square plus 4. This is the dividend. In this you could not find x cube term and x term. Therefore we wrote this as x power 4 plus 0x cube minus 3x square plus 0x plus 4. Now this is divided with x minus 2. Now in actual division what to do is you have to divide the first term with this first term in the divisor. X power 4 by x is x cube. Now you multiply both these terms with x cube. X cube into x is x power 4, minus 2 into x cube is minus 2x cube. Now you subtract. If you subtract, plus x power 4 minus x power 4 will be get cancelled, and this may become minus 2x cube may become plus 2x cube. Therefore this is plus 2x cube minus 3x square. Again you divide the first term with the first term of the divisor. 2x cube by x is 2x square. You multiply both these terms with 2x square now. 2x square into x is 2x cube, minus 2 into 2x square is minus 4x square. You subtract again. If you subtract, these two will be cancelled. Minus 3x square plus 4x square is plus x square. Plus x square plus 0x plus 4. This is now the new dividend. Now in order to go for the division, again divide the first term with this first term, that is x square by x. X square by x is x, isn't it? Now you multiply both these two terms with x. X into x is x square, minus 2 into x is minus 2x. You again subtract now. If you subtract, plus x square and minus x square will be cancelled, and this will be plus 2x, and this is plus 4. Again divide the first term with the first term. 2x by x is 2. Now 2 into x is 2x, and 2 into minus 2 is minus 4. If you subtract, plus 2x and minus 2x will be get cancelled, and this is plus 4. Minus of minus 4 will also be plus 4. 4 plus 4 is 8. You see, using remainder theorem you found the remainder as 8, and if you perform the actual division, again we got the remainder 8. Therefore it is verified, isn't it? Therefore the remainder when f of x is divided by g of x, x minus 2, is equal to 8. Dear children, all the video links of Introduction to Polynomials and all the questions and solutions from exercise 2.1, 2.2 and 2.3 are given in the description. You can click them and you can observe the videos and you can solve the problems. Thank you. Thank you, one and all.